There's a cable you can buy on Amazon for about $49. Honda sells it for their inverter generators. So does Champion, Yamaha, Westinghouse. It's called a parallel kit, and the idea is simple. Plug two inverter generators into it, and they combine their power into a single output. Twice the watts from two smaller machines instead of one big one. That's inverter generator parallel operation, and understanding how it actually works is the part the listing leaves out. The listing makes it look like the kit is doing the work, like that cable is the engineering. It isn't. If you tear one of these kits apart, what you'll find inside is a short run of copper wire and a junction box. There's nothing smart in there, no microprocessor, nothing that regulates or synchronizes anything. Some of them are literally just a Y-shaped extension cord with a combined outlet on one end. The actual technology that makes two generators run in lockstep, keeping their electrical output synchronized down to the millisecond, is buried inside the generators themselves, in a chip most owners don't even know exists. That's the part of the story nobody tells you when they show you the cable. Paralleling sounds like it should be straightforward. You have two generators, you connect their outputs, and the electricity adds up. In principle, that's correct. Two machines feeding the same circuit, sharing the load between them. But the moment you try to do it, you run into a problem that electrical engineers have been dealing with since the early days of power generation. Alternating current doesn't just flow, it pulses. 60 times per second in North America, the voltage swings from positive to negative and back again. That wave has a shape, a speed, and a timing. When you connect two generators to the same circuit, those waves have to be virtually identical. The voltage has to match, the frequency has to match, and the waves have to peak at exactly the same moment, what engineers call phase alignment. If even one of those is off by more than a narrow margin, the generators don't cooperate. They compete. I think that's the detail most people never consider. It's not about raw power, it's about rhythm. When two generators are out of sync and someone closes the connection anyway, the result isn't a gentle mismatch. It's violent. The current spike that hits both machines can be several times their rated capacity, comparable to a dead short circuit. On industrial generators, engineers have documented torque transients strong enough to crack drive shafts and shear coupling bolts in a single event. There's a case from the marine industry that power engineers still reference. A ship generator was accidentally paralleled while out of phase, and the resulting reverse power drove the unit into what's called motoring, where electricity flows backward into the machine and forces it to spin as if it were an electric motor instead of a generator. The diesel engine on the other end couldn't absorb the torque. According to the account, the generator tore free from its mounting frame and pushed through the bulkhead behind it. That's an extreme case, and it happened on equipment weighing several tons. But the underlying physics scales down. Even on smaller machines, an out-of-phase connection creates circulating currents between the two generators, electricity flowing in a loop between them instead of into the load. Those currents generate heat, and they can damage windings and internal components within seconds. The machines don't share the work. They destroy each other. The reason this problem stayed unsolved for consumers until the late 1990s is that conventional generators can't synchronize themselves. Their alternators produce AC directly from the spinning engine, and keeping two of those locked in phase would require the kind of protective equipment you'd find in a power plant: synchronizing relays, reverse power protection, load-sharing governors, equipment that costs more than most people's houses. Automatic voltage regulators, or AVRs, handle the voltage side on conventional machines, but they can't solve the phase problem on their own. Inverter generators took a completely different route. Instead of trying to synchronize two spinning machines, they removed the problem from the mechanical side altogether. The alternator output is first converted to DC, then rebuilt from scratch as a clean AC sine wave by a microprocessor using pulse width modulation. The waveform is built digitally, which means it can be adjusted with a precision that no engine governor could ever match. The result is power with less than 3% total harmonic distortion, which is why inverter output is considered clean enough to run sensitive electronics like laptops and medical equipment that conventional generators can damage. Honda brought this to market in 1998 with the EU9i, the first portable generator in its class, built around a computer-controlled inverter. Paralleling was part of the pitch from the beginning. That single product established the template that every parallel-capable inverter generator since has followed. That digital control is what makes consumer paralleling possible. When you connect two inverter units with that $49 cable, the first machine you start becomes the frequency reference. The second one detects that signal and locks onto it. The synchronization that used to require a trained operator watching a synchroscope happens automatically inside a chip smaller than a postage stamp. This is where a lot of people get frustrated. Every manufacturer says the same thing, only parallel identical units, same brand, same model, in some cases the same production run. Honda's lineup is a good example of how precise this gets. Their entry-level EU1000i can parallel with another EU1000i. The mid-range EU2200i pairs with another EU2200i. But Honda warns that connecting an EU2200i to certain older EU2000i serial number ranges can cause low voltage output, dropping from the expected 120 volts toward levels that risk damaging whatever you've plugged in. And the kits themselves aren't cross-compatible either. WEN states that its inverters are designed to communicate only with other WEN generators. It sounds like a sales tactic. Buy two of ours, not one of theirs. But there's a technical reason behind it, and it comes down to something most people would never think to check. Each manufacturer programs its inverter to target a slightly different output voltage. One brand might regulate to 122 volts. Another might aim for 118. Forum testers have measured differences of around 8 volts, sometimes 118 volts versus 122 volts, between a Honda and a Harbor Freight unit running side by side. Connect those two, and the higher voltage machine sees the lower voltage one as a partial load. It pushes current into the other generator instead of into your equipment. One unit overworks, while the other barely contributes. Over time, that imbalance burns out the machine doing all the heavy lifting. And the parallel cable can't fix that. It was never designed to. It's copper wire and a junction box, the intelligence that keeps two units matched lives in their firmware. Same model means the same firmware running the same synchronization logic. That's not marketing. That's how it works. For people running these setups in RVs, it's worth knowing that the combined output typically feeds through a standard NEMA TT30 connector, the 30-amp RV plug, or in larger setups, a NEMA 1450 for 50-amp service. Knowing your plug standard matters when you're sizing whether a parallel pair actually meets your rig's shore power requirements. Here's what's worth stepping back and acknowledging. If you parallel two identical inverter generators using the manufacturer's cable and follow the instructions, the process is remarkably safe. The microprocessors handle the synchronization. The cable carries the combined output. It works. Carbon monoxide is the single biggest killer. According to the Consumer Product Safety Commission, roughly 85 people die in the United States every year from CO poisoning caused by portable generators. That's an annual average from 2017 to 2019, and over 80% of those deaths happen inside homes, garages, basements, rooms where someone ran the machine with the door cracked open, thinking the gap was enough. Honda's newer inverter models now include automatic CO shutoff technology, sometimes called CO minder, that detects carbon monoxide buildup and shuts the engine down before levels become dangerous. It's the kind of feature that should be on every portable generator sold. The second major hazard is backfeeding. That's when someone plugs a generator directly into a wall outlet using a male-to-male extension cord, sometimes called a suicide cord for good reason. It bypasses every circuit breaker in the house. It can start fires inside the walls. and it re-energizes the utility lines outside, which means a lineman working on what he believes is a dead wire can be electrocuted by a generator running 3 blocks away. In September 2022, the CPSC issued a warning urging consumers to immediately discard these cords. The correct solution is a transfer switch. A properly installed transfer switch or interlock kit wired by a licensed electrician that physically disconnects your home from the utility grid before the generator feeds power in. That's what makes home generator connections safe, not a $49 cord with 2 male ends. Neither of those problems has anything to do with paralleling, but they're the context every generator owner should understand. So the next time you see a parallel kit listed online for $49 and wonder whether it's really that simple, the answer is yes and no. Yes, the cable works. 2 identical inverter generators, the right kit, and you get double the output. It's one of the most useful features in the portable generator world, and when it's done properly, it's safe. But the cable isn't what makes it work. 25 years of inverter engineering is what makes it work. The microprocessor that builds the waveform from scratch. The pulse width modulation that sculpts a clean sine wave with less than 3% THD. The firmware that locks 2 machines into the same rhythm without a human operator in the loop. All of that is hidden inside the housing, doing its job in silence, while the cable gets the credit. I think there's something worth respecting in that. The best engineering is usually the kind you never notice, until you try to do without it.